All right, so today we're going to be talking about Chapter 7, Lesson 6. This is all about cross-sections. So cross-sections are when we start talking about a plane that cuts through some kind of solid. Now, a plane is a flat surface that goes on forever in all directions. It's kind of like a three-dimensional line. A line goes off in both directions forever. A plane goes off in all three directions forever. So the figure at the right shows rectangle ABCD. That happens to be this rectangle here. It looks kind of like a square. Now line segments AB, that's going to be this one all across here, and we show that by saying AB with a little line across the top. And line segment DC, which is going to be along the bottom here, and again we show that by saying DC with a line over the top. Those lines are called coplanar, and basically the only reason why they're called coplanar is because they're on the same plane. They're also parallel though, because they will never ever intersect, no matter how far we extend those lines. Now, just as two lines in a plane can intersect or be parallel, there are also different ways that different planes can intersect. For example, we could talk about intersecting in a line, and in that case, we would have two planes where they cross, and they'd have a line where those two met. We'll talk about what this line actually is soon. We could also have them intersect at just one specific point. So we could have still these two planes, which happens to be this one and this one. But we could also have a third one that kind of cuts through everything. And the only place where all three of those would meet would be here at this specific point here. And we'll talk about what that point is called as well. Now, we could have planes that intersect, two of them. We could have three planes that intersect, or we could have no intersection. And in this case, this would also be called parallel planes. So if we look at this rectangular prism here, this first one, HG, that's intersecting in a line. That's where two planes intersect right here, and we call that an edge. So an edge is where two planes intersect in a line. We could also look here at this point E, and this would be where 1, 2, and 3 planes intersect. So this would be intersecting at a point, and this is called a vertex. I'm going to highlight that because that's an important word. And a vertex is where 3 planes intersect at a point. Now, each one of these planes, there's one across the top, there's one on the bottom, and there are 4 going around. Each one of those are called faces. Again, we're going to highlight that because that's an important word. And these are flat surfaces of figures. And then this last one right here goes from H down to B. There would also be one from G diagonally across to A, D down to F, and E up to C. These are called diagonals. And I'm going to highlight that one as well because that one's also important. So a diagonal is a line segment that cuts through the middle of a solid It has endpoints, which is where it ends. So in this case, this diagonal here would be H and B. that aren't next to each other. And not on the same face. And then the last thing we're going to be talking about is something called skew lines. These always come in pairs. So skew lines are lines that don't intersect. And not on the same face. Now that might be a little bit confusing, but we're going to go ahead and start looking at some of these examples here. So, example 1. It says identify the figure, then identify the bases, faces, edges, and vertices. So, identify the figure. This right here is a pyramid. We know that it's a pyramid because it has only one base, and the faces around it are triangles. And this is a rectangular pyramid because the base is a rectangle. So we're going to call this a rectangular pyramid. Now we want to identify the bases, faces, edges, and vertices. So the base is always going to be what this first word is dealing with. So in this case, it's a rectangle. And this rectangle is going to be labeled by its vertices. So we have A, B, C, and D. So our base is A, B, C, and D. The faces are everything that's not a base, which would be these triangles along the side. So we go A, B, E is one face. That's this front triangle right here. So we can say A, B, E. In fact, E should be the last letter in all of these because E is going to be the pinnacle of this pyramid. The next one would be B, C, E. We're going to have C, D, E. And then A, D, E. Edges are going to be these line segments here. So we'd have AB as one of them, with a line segment. We'd have BC. We'd have CD. We'd have DA, or you can say AD, it doesn't matter. And then we have each one of those letters also A up to E. B up to E, C up to E, and D up to E. And then the vertices would be all of the letters because they're on the corner. So A, B, C, D, and E. Last thing I want to talk about is skew lines, so let's write that in. Now, we only have to write one pair of skew lines. So what we're going to look at is I just want to pick one line, and I like AB just because it's in the front. So what I want to do is I want to pick a line that it's not going to intersect with, which this line it intersects with, so we don't want that one. This line it intersects with, so we don't want that one. This line it intersects with, so we don't want that one. And this line it intersects with, so we don't want that one. We also want to get rid of any other line that's on the same face. Now, luckily, we got rid of 2 of the other 3 lines, but this back line is on the same face as well. So the only lines that are left are this one here, DE, or this one here, CE. So I'm just going to write down one of them. And those are skew lines. All right, example 2 now. This here is going to be a triangular prism. The reason why it's a prism is because we have 3 faces that are rectangles, and then 2 that are triangles. So this is going to be a triangular prism. Nope, figure name is on the top here. So this is a triangular prism. I'm going to write down skew lines here as well, because we want to do those. Bases. Now, with a prism, we have 2 bases. And the bases are going to be triangles. So that would be this right in here, ABC, and DEF. Faces are the other rectangles, so ABED. We have BCFE. So we've done this front one, we've done the back one. Now we need to do this one on the bottom, which would be ACFD. And that's all the faces. And it should make sense, because if we add the bases together plus the faces, we would get the total number of sides. There are 2 bases and 3 faces, so that'll be 5. We have 2 bases shown and 3 faces written, so that would also be 5. Edges now. This is going to be every single one. So AB is 1. BC. CA. We also have BE. AD. And CF. That'd be going from the base up to the other triangle. And now this last triangle, we'd have DE. We'd have EF. And DF. A lot of writing. Vertices, all of the letters. We have A, B, C, D, E, and F, putting commas between to show that they are separate vertices. And then last but not least, skew lines. Again, I'm going to pick this front line here, AD. And because skew lines come in pairs, I have to write another one. Now, I'm going to get rid of every single line that it either intersects with or is on the same face. So this line here is the one I want. This one it intersects with. And this one it intersects with. This one it intersects with. This one it intersects with. But it doesn't intersect with any other line. Now we want to get rid of the ones on the same face, which means it forms this bottom face here, so this back line we want gone. And it helps form this front face, so this line we want gone also. And now there are only 2 lines that it could be, either BC or EF. And I'm just going to say BC. Now, last but not least, we're going to deal with cross sections. Now, a cross section, this is going to be the intersection of a solid and a plane. The important thing is we're going to be looking at the intersection. So if we look at this first cross section, we could be talking about a vertical one. So V, this is vertical. H would be horizontal. And D would be diagonal. So it says describe the shape resulting from a vertical, horizontal, and diagonal cross-section of the shape below. So if we go ahead and do it vertically, we're going to have something that looks like this. So this is going to be some kind of rectangle. If we do it horizontally, that means we're going to be cutting it in half. So we're going to have something that looks like a triangle. And if we angle it, that means we're going to be kind of going across like this. Notice how we have a line here and a line here, and then we'll have some kind of diagonal going here, and that's going to be a trapezoid. So the vertical one, it's going to look like this. A horizontal one, it's going to look like this. And the diagonal one, it's going to look kind of like this. All right, so that is going to be the end of lesson 6. If you have any questions, please let me know.